So the first topic is acids. Now what are acids? So bases are those substances, as already told you. So we are going to talk about three important indicators. First of all, what are indicators and how the color changes in all of these, okay? Characteristic property of acids. First we are going to talk about acids and then bases. How does an acid react with a metal? Now let's move on to the next type of reaction of acids with base. Hello and welcome back, students. So today in this video we are going to do your part 2 of acid, bases and salt. I hope you have watched the part 1 already. If not, then go check out. You will find the link in the description box below. And in part 1 we discussed what are acids, what are bases, their properties and their reactions. Okay, here we are going to discuss about the H plus ion, which is also known as proton, then universal indicator, then the difference between strong and weak acids, then effect of concentration on strong and weak acid. Thus concentration plays an important role to change the term of acid, strong acid and weak acid. Next is your pH scale. How do we know if any acid or base is strong or weak? Then pH color interpretation, then neutralization of acid and alkali. We have already discussed the neutralization reaction in part 1. We'll do it again in detail. Then classifying oxides. So there are basic oxides, acidic oxide and then amphoteric oxide. We are going to talk about that. So first let's understand what is a H plus ion and why is it important to understand in acid, base and salt. So H plus, which is also known as proton. Now you must be wondering why it is known as proton. Proton is a subatomic particle which is present in nucleus, but H plus is also known as proton because hydrogen atomic number is 1. We know that atomic number of hydrogen is 1. It means it has 1 proton present, and for it to be neutral, 1 electron will be present. Now it has donated 1 electron and hence it possesses a positive charge. It is H plus now. It means that it is only left with 1 proton and hence it is also commonly known as proton. I hope it is clear. Next, an H plus ion is a proton because a hydrogen atom has 1 proton and 1 electron. When it loses the electron, only the proton is left and hence it is known as a proton. Next, therefore, when a hydrogen atom loses its 1 electron, it becomes an H plus ion, which is just a proton. Proton transfers strong and weak acid. Now let's talk about acid or H plus in terms of acid. Okay. Now we know what are acids. Acids are those substances which release H plus when dissolved in water. Okay. And bases are those substances which release OH minus, or I can say hydroxide ions. Okay. So this was the difference between acid and base, which we have already studied in your part 1. Here acids are proton donor. So acids are those substances which can donate H plus. Like for example, you have HCl. Okay, it can donate H plus plus Cl minus. Okay, as they ionize in solution. Ionize means that they break down into its ions. Like for example, HCl here is breaking down into its ions, which are H plus and Cl minus. Okay, next is producing protons, which are H plus ions. These H plus ions make the aqueous solution acidic. So because of the presence of H plus or proton, the solution becomes acidic, and because of the presence of OH minus, the solution becomes basic. Next, bases are proton acceptor. So here in this particular slide, we are basically understanding the acids and bases in terms of proton. Okay, one of them is proton donor and the other is proton acceptor. So the one which is proton donor is your acid and the one which accepts proton is your base. This you should know. Okay, next, as they accept the protons that are donated by the acid. So acids are those substances which donate protons and the substance which accept those protons are known as bases. Okay, now please quickly make note of it. Alright, now let's move on ahead. So universal indicator. Now what is universal indicator? It looks something like this, where we have different shades of color and it tells us, it is basically a mixture of different dyes or indicators. A universal indicator is a mixture of different indicator which is used to measure the pH. So this tells us that how strong a acid is or how weak, or if any solution is basic, then how strong or how weak. Okay, a drop is added to the solution and the color is matched. Okay, so for example, you have two beaker A and beaker B. Okay, here two different solutions are present. In one of them acid is present, in another base is present, and we have to check in which beaker acid is present. So what do? We put a drop of this in the solution, and the color whatever changes, we match this with the table given over here, and then we get to know that if the solution is acidic or basic. If it is acidic, then what is the strength of that acid? Okay, like for example, if it is strongly acidic, then it will be red or brown in color, okay, or maybe shade of pink. If it is weak acid, then the colors will be beige, yellow, lime green, right? If it is neutral, neutral means it is not acidic, not basic. It means H plus ions concentration is equal to OH minus concentration. This means the neutral solution. Then it will be green in color, the 7. Okay, if it is strongly basic, then the color will be dark blue, violet or purple. If it is weak basis, then blue, pale blue, turquoise and dark green colors can be seen, right? So this is the way, this is the universal indicator. Next, let's talk about strong and weak acid. Now we know the difference between acid and base. We know from the universal indicator that there are different colors which can help us tell that if the acid is strong or weak, or the base is strong or weak. But what is the difference between strong acid and weak acid? So let's understand. For example, you have a strong acid which we already know, HCl, which is hydrochloric acid. So when HCl dissociates completely into its ion, or I can say when HCl completely ionizes into its ion in aqueous state, then it is said to be a strong acid. Okay, when it completely, this is the important term, when it completely dissociates or ionizes, dissociates, or you can use the word ionize, okay, then it is said to be strong acid. And what are weak acids? For example, you have acetic acid or ethanoic acid. Here it does not completely ionize into its ion, but partially ionizes. When any acid partially ionizes, okay, or dissociates, then that is known as weak acid. Weak acid. Right? Now, CH3COH is breaking down into its ion to give CH3CO minus and H plus, okay, and this reaction is reversible, so we can get back our acetic acid or the ethanoic acid, right? So when partially dissociates, that is your weak acid. When completely dissociates, that is your strong acid. Same concept goes with your bases also. If any base, like we know strong base is NaOH, which is your sodium hydroxide, it completely breaks down into its ion, then it is a strong base. And if any base which is weak, it does not completely break down in its ions, then that is known as weak base. Now let's read quickly. A strong acid is an acid that completely dissociates into in an aqueous solution, meaning all of its molecules break apart into ions. Like for example, your HCl, or another example we can take is HNO3. Another example we can take is your sulfuric acid. Next, a weak acid is an acid that partially dissociates in an aqueous solution, meaning only some of the molecule breaks apart. Okay, only some, partial dissociation. That is your weak acid, like for example, your ethanoic acid. I hope this is clear. If you wish to note down this, you may do. Alright, I hope you have written this. Now let's move on to the next part, which is effect of concentration on strong and weak acid. Now you must be wondering what happens if we increase or decrease the concentration of acid. Does it affect their strength also? So let's read. A concentrated solution of an acid is one that contains a higher number of acid molecule per dm cube. Basically, if we are taking 1 dm cube volume of acid and more number of H plus ions are present, then it is said to be strong acid. Okay, it does not necessarily mean that the acid is strong. though as it may be made from a weak acid which does not dissociate completely. So it doesn't necessarily means that if the concentration of H plus ion is greater, then it is going to be your strong acid only, because those H plus ions can also come from the weak acid. Okay, we never know. For example, a dilute solution of HCl will be more acidic than a concentrated solution of ethanoic acid. Definitely. Why? Because HCl will 100% break down into its ions. So even if it is diluted, number of H plus remains the same if we are comparing it with the same volume. Okay, but ethanoic acid, because it is a weak acid, we already know, it will not completely dissociate into its ion, it will partially dissociate, hence the concentration of H plus will be lesser. Since most of the HCl molecule dissociate, but very few of the CH3COOH do, okay, which is your ethanoic acid. So let's move on to the next, which is your pH scale. Now the pH scale is from 0 to 14. If the value comes from 0 to 6, then it is said to be acidic solution. If it is 7, then neutral, then beyond 7 it is basic. Now strong acids are the one which are at the end of the scale. So these are the stronger acids value, this is the weak acid value, these are the weak base value, this is strong base value. So this is a pH scale. Okay, acid, strong acid. So you should know this, that at the extreme ends of the pH scale lies the stronger acids and bases. Okay, next, the pH scale and hydrogen ions. Now more the H plus ions, or when we get more of H plus ions, it means strong acid, it means it is dissociating completely, right? We have already seen that acids are substances that contain hydrogen ions in solution, we know that. The more hydrogen ions, the stronger the acid, but the lower the pH, which is obvious, right? Because the strength of the acid increases as the concentration of H plus ions increases, and that will give us the value from 0 to 3. Right. Next is the higher the concentration of hydroxide ions. Hydroxide is your OH minus ions, which is given by your bases. So more the concentration of OH minus, stronger is the base, and therefore the values will lie over here, right? But they have an inverse relationship. The pH is a measure of the concentration of H plus in the solution, but they have an inverse. Okay, this is important. This you should know. So what is pH? If you have to write the formula of pH, then it is potent of hydrogen, pH equals to minus log and concentration of H plus. Okay, this is how we calculate pH. So minus log of concentration of H plus ions. The pH scale is logarithm, meaning that each change of 1 on the scale represents a change of concentration by a factor of 10. Okay, and if you wish to write down the formula, then this is how we calculate pH. The acid strength is reflected in how many hydrogen ions are in solution. The more hydrogen ions, the lower the pH, and vice versa. Okay, the lesser the H plus ions, the more is the pH here. Okay, now please note this down. Okay, I hope you have written this. Now let's move on to the pH color interpretation. Now in acidic, as we have already discussed, it's from 0 to 6, and the ones which are strong acid, they lie to the extreme of this pH scale. Okay, and here the pH for base is 8 to 14. The ones which are stronger lies to the extreme of the pH scale, okay, towards this side. Now acidic, which is pH less than 7, turns red to yellow. Lower pH means higher H plus concentration, and closer to 0 means stronger acidity. We have already understood. Next is neutral, which is this one. So this turns green. Equal concentration of H plus and OH minus, which we have already discussed here in the beginning itself. In this slide I told you, if the concentration of H plus and OH minus is equal, then it is said to be a neutral, okay, neutral solution. And the pH of which is 7. The color it shows in the universal indicator is green. Next is your alkaline. Okay, so pH more than 7 turns blue to purple. Higher pH means greater OH minus. Ion concentration closer to 14 means stronger alkalinity. Okay, so stronger alkalinity means stronger base. More of OH minus ions will be released. Okay, next is your neutralization of acid and base. So we have done neutralization reaction in the part 1 itself, but let's understand this one more time. So what is neutralization reaction? So as the name suggests, neutral. Okay, it means when we react acid and base, or when we mix acid and base, they neutralize each other. The acid neutralizes the base and the base neutralizes the acid. Okay, and what happens, like for example, HCl is a strong base plus HCl is a strong acid, SA strong acid, NaOH which is sodium hydroxide is a strong base. This react to give us H2O plus salt, which over here is NaCl, with this and these. Okay, so water and salt is the products which we get. The acid provides ion H plus and alkali provides hydroxide ion. When these two combine, they form water. We know, look, H plus and OH minus gives water. Okay, the overall effect is to neutralize the acidic and basic properties. The skeletal reaction, if you wish to note down the skeletal reaction, then it is acid plus base. The reaction we are writing for neutralization reaction. Okay, acid plus base react to give us salt and water. Okay, so you can write this. Next, let's move on to classifying oxides. Now, what are oxides? Oxides are those compounds in which oxygen is combined. Okay, so oxides are compound made from one or more atoms of oxygen combined with one other element. Like for example, magnesium oxide, zinc oxide, potassium oxide, CO2 which is carbon dioxide, then sulfur dioxide, and then water. Now, oxides can be classified as acidic oxide, basic oxide, or amphoteric oxides. Now, what are acidic oxides? So, okay, so what are acidic oxides? For example, you have a metal attached with oxygen. Okay, metal with your oxide, then let me write down metal oxide, right? And they are basic in nature. So they are also known as basic oxides, basic oxide, right? Similarly, if you have non-metal attached with an oxide, okay, then that is known as your non-metal oxide, and it is acidic in nature. Okay, it is acidic in nature, so it's very easy. So this is known as acidic oxide. Acidic. So let's read about it. Acidic oxide. Acidic oxide are those formed when a non-metal element combines with oxygen. They react with base to form salt and water. Okay, so let's write down over here acidic oxide, which are your non-metal oxide, okay, NMO, plus when they react with base, they give salt and water, right? When dissolved in water, they produce an acidic solution and hence they are known as acidic oxide with a low pH. So acidic solution means low pH only, right? Common example are CO2, SO2, NO2, SiO2. So when NO2 reacts with water, it gives nitric acid, SO2 sulfurous acid, and similarly CO2 means carbonic acid, which is acidic in nature. Next is your basic oxide. It means they are talking about metal oxides, which are basic in nature. So are formed when metal element combines with oxygen. Here we have already written they react with acids to form. Okay, so when we react them with acid, they give us salt and water. So do you see these two skeletal reactions? These NMO, which is non-metal oxide, when reacts with your base, it gives us salt and water. And when MO, which is your metal oxide, when react with acid, they give us salt and water. Next is when dissolved in water, they produce a basic solution and hence the pH rises. Therefore, they are known as basic oxide. Some common example are CuO and calcium oxide, which are your metal oxide. Okay, CaO is your quicklime, right? Now, please make note of it. Okay, now let's move on to understand this on the periodic table. So this side we have metals, right? These all are metals, the one which are in blue. And metal oxide, as I told you in the previous slide also, metal oxides are basic in nature because when they react with the, when they react with the acid, they form salt and water. And when they are dissolved in water, they produce basic solution. Hence, they are basic in nature. Therefore, these metal oxides are all basic in nature. The one which are in the right side of the periodic table, these, the yellow ones, these all are non-metal. Hence, when they react with oxygen, they form NMO, which are non-metal oxides. Okay, and the purple one, which are metalloids, which have property which possess property of both metal and non-metal. Some properties of metal, some with non-metal. So these are known as your metalloids, and these are your, let's talk about them in the next slide, okay? So this is your next slide, wherein we are going to talk about your amphoteric oxides. Now, as the name suggests, amphi means both, okay? So let's understand neutral oxides. Some oxides do not react with either acid or base and thus are said to be neutral. Some examples include N2O, NO, and CO. Now, N2O, let me give you a fun fact about N2O. N2O is the laughing gas, okay? This N2O. You can research about it a little more if you are interested. Next is amphoteric oxide. So let's come and talk about this important point. Neutral oxide, you already know, the ones which do not react with acid or base are your neutral oxide, N2O, NO, and CO, carbon monoxide. Then now, what is amphoteric oxide? Amphoteric oxides are a curious group of oxides that can behave as both acidic and basic. Okay, so amphi means both, which can act as both acid and base, whether the other reactant is an acid or base. In both cases, salt and water are formed, obviously, because acids and base, they both react with, like NMO and MO, both reacted with acid and base to give salt and water, right? So similarly, what are amphoteric oxides? The one which can react with acid and base both to give salt and water. Okay, in both cases, salt and water are formed. Like for example, let's say amphoteric oxides are AO plus, either we make them react with acid or with base, we will get the same salt and water. Next, two of the most common amphoteric oxide, very important, zinc oxide, which is your ZNO, and aluminium oxide, Al2O. They both are amphoteric oxides. They can react with both acid and base. Okay, the hydroxide of both of these elements also behave amphoterically. Example of aluminium oxide behaving as a base. Now these reactions are very important. So when aluminium oxide reacts with an acid, it will give us this salt and water. And aluminium oxide can, because it is amphoteric, so it can react with both acid also and base also. If you write the reaction with the base, then you will get NaAlO2, which is the salt, and water. So if somebody asks you to write the equation and explain it, what amphoteric oxide is. So first of all, amphoteric oxides are the one which can react with both acid and base to give salt and water. Example are zinc oxide and your aluminium oxide. And the reaction of aluminium oxide you can show by reacting it with acid first and then with the base. And in both the reactions, first we will get a salt and then water, right? Please make a note of it. Alright, so here we come to an end of your part 2 of acid, bases and salt. I hope your concepts are clear. If you have any doubt, feel free to comment down below and I'll get back to you. And we'll be coming with the part 3 really soon. That is going to be the last part of acid, bases and salt. So till then, stay tuned and enjoy. Thanks for watching and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.